Welcome to this model. In this model, I'm gonna speak about ultrasonic therapeutic unit. Ultrasonics are used for therapeutic purposes in the same manner as a shortwave diathermy machine is used. The heating effect in this case is produced because of the ultrasonic energy absorption property of the tissues. The property of specific heat distribution in tissues or the additional effect of a mechanical component have given rise to a number of special therapeutic applications of ultrasonics. The effect of ultrasonics on the tissues is thus a high-speed vibration of micromassage. Massage as a modality in physical medicine has been used in the treatment of soft tissue lesions for centuries. Ultrasonic energies enables this massage to be carried out firstly to a greater depth than is possible manually, and secondly at times when pressure cannot be exerted by hand because of the intolerable pain caused to the patient. The thermal effects of ultrasounds are dependent on the amount of energy absorbed and the length of time of the ultrasound applications and the frequency of the ultrasound generator. The electrical power required in most of the applications is usually less than 3 watts per centimeter square of the transducer area that is in contact with the part of the body to be treated. Ultrasonic generators are constructed on the piezoelectric effect and the high frequency alternating current, for example 0.75 to 3.0 megahertz, is applied to a crystal whose acoustic vibration causes the mechanical vibration of a transducer head, which itself is located directly in front of the crystal. These mechanical vibrations then pass through a metal cap underneath the body tissue through a coupling medium. The therapeutic ultrasonic intensity varies from 0.5 to 3.0 watts per centimeter squared. Applicators ranges from 70 to 130 millimeter in diameter, and the larger the diameter of the applicator, the smaller would be the angle of the divergence of the beam and the lesser the degree of penetration. This diagram shows the block diagram of ultrasonic therapeutic unit. The equipment required for ultrasonic therapy is electronically very simple. The heart of the system is a timed oscillator which produces the electrical oscillations of the required frequency. The oscillator output is given to a power amplifier which drives the piezoelectric crystal to generate ultrasound waves. Power amplification is achieved by replacing the transistor in a typical LC tuned Colplit oscillator and by 4 power transistors placed in bridge configuration. The delivery of ultrasound power to the patient is to be done for a given time, and this is controlled by incorporating a timer to switch on the circuit. The timer can be a mechanical spring-loaded type or an electronic one, allowing time settings from 0 to 30 minutes. The output of the oscillator can be controlled by either of the following two methods. One is by using a transformer with a primary winding having multi-tapped windings and switching the same as per requirement. And the second method is controlling the firing angle of a triac placed in the primary circuit of the transformer and thereby varying the output of the transformer. And the power output in the case of triac controlled machines can be continuously varied from 0 to 3 watts per centimeter square. The machine can be operated in either continuous or pulsed mode. A full wave rectifier comes in the circuit for continuous operation, and the main supply is given to the oscillator without any filtering. The supply voltage is therefore 100 Hz, which causes the output 1 MHz to be amplitude modulated by this 100 Hz. In pulsed mode, the oscillator supply is provided by the half-wave rectifier and the oscillator gets the supply only for a half cycle. Thus, the output 1 MHz is produced only for one half of the cycle and is pulsed. The transducer may be barium titanate or lead zirconate titanium crystal having 5 to 6 centimeters square. And it has the effective radiating area of around 6 centimeters square, and the length of the cable connecting the transducer with the oscillator is of critical dimension and should not be altered. In front of the crystal lies a metal faceplate which is made to vibrate by the oscillations of the crystal. Ultrasonic waves are emitted from this plate, and the crystal has a metal electrode pressed against its back surface by a coiled spring. Voltage is applied to the crystal via this electrode, and the front diaphragm is grounded and provides a return path for the excitation voltage. And the dosage can be controlled by varying any of the following variables. For example, by varying the frequency of ultrasound, intensity of ultrasound, and the duration of the exposure. The frequency is involved because the absorption of the ultrasonics by the tissues is a frequency dependent phenomenon, and the question as to which the ultrasonic frequency to use has been the subject of much investigation and the thought, but it has been established that a frequency of approximately 1 megahertz is most useful. The amount of energy absorption in the human tissues has been measured experimentally, and in soft tissue, a reduction of 50% occurs with the 1 megahertz ultrasonic transmission at a depth of 5 centimeter. Okay, and the higher the frequency, the quicker the energy loss, and thus with the transmission of 3 megahertz, this reduction of 50% occurs at a depth of only 1.5 centimeter. Below a frequency of 1 megahertz, the beam of ultrasonic energy tends to diffuse and no efficient treatment can be expected. A frequency in the range of 800 kilohertz to 1 megahertz is therefore most widely adopted. Unlike the operation of shorter therapy unit, no tuning is necessary while the treatment is in progress. The operating frequency is also not very critical and may vary to the extent of plus or minus 10%. The output power of the ultrasonic therapy unit can be varied continuously between 0 and 3 watts per centimeter square, and the calibrated positions are marked in steps. The steps indicate the average value of intensity monitored in terms of electric power converted into acoustic energy. Standard values concerning dosing in ultrasonic therapy have been established on the basis of experimental studies. So, in order to achieve maximum therapeutic efficiencies, it is necessary to ascertain the correct ultrasonic intensity and duration of application for a given indication. To make matters simpler, some instruments are equipped with a dose tabulator from which the data concerning dosing can be taken at a glance. So, in this table, dose mark is given for every indication, and all that is required is to set a pointer appropriately to ensure that the apparatus is providing the correct output intensity. Apart from continuous and mains frequency modulated modes, the ultrasonic outputs can also be modulated by any other frequency. The idea behind a pulsed operation is that the predominant effect of ultrasound is not the heating effect but the direct mechanical effect, and the thermal effect is reduced by repeatedly interrupting the supply of energy through brief pauses. And now let us see the application techniques of ultrasonic therapeutic unit, and there are several ways for applying the ultrasonics to the body. The probe can be put into a direct contact with the body through a couplant provided the part to be treated is sufficiently smoothed and injured. In case of long areas to be treated, the probe is moved up and down, and for small areas it is given a circular motion to obtain the uniform distribution of ultrasonic energy. And if there is a wound or uneven part, the treatment may be carried out in water bath, and this is to avoid a mechanical contact with the tissues which may damage an already injured tissues, and it should be ensured that the air bubbles are not present either on the probe or the skin. For this treatment, any vessel with warm water would be suitable, and the part of the body to be treated is rubbed with alcohol and soaped. The probe is moved over the area to be treated but held at a distance of about 1 to 10 cm from the area under treatment, and this method is not generally preferred because of the difficulty of controlling the exact amount of dosage. The probe can be put into direct contact with the body through the couplant, and the dosage can be controlled by the following methods as I said earlier. Ultrasonic therapy or ultrasonic diathermy products used in physical therapy equipment produce high frequency sound waves that travel deep into tissue and create gentle therapeutic heat. Ultrasonic diathermy is intended to generate deep heat within the body tissues for the treatment of selected medical conditions such as pain, muscle spasms, and joint contractions, but not for the treatment of malignancies. And the sound waves are transmitted through a round-headed wand that therapist applies to the skin with gentle and circular movements. A hypoallergenic gel aids in the transmission of the ultrasonic energy and prevents overheating at the surface of the applicator. Treatments usually last between 5 to 10 minutes as I said earlier, and the ultrasonic therapy doesn't hurt. There may be a bit of tingling sensation and or a sensation of warmth if a therapist keeps the wand moving continuously. If, however, the wand is held in place for more than few seconds, and it can become uncomfortable at higher energies. While ultrasonic therapy can be used to treat the conditions described above, It is important to know that there are situations and areas of the body where it cannot safely be used. You should notify the practitioner administrating the ultrasound if any of the following applies to you. For example, if you have a cardiac pacemaker, if you have malignancy in the area of the area to be treated, you have a healing fracture in the area to be treated, you are pregnant and you have an implanted medical device other than pacemaker, such as implanted deep brain stimulation device. You should also aware of the commercial ultrasonic diathermy devices may exist that have been formally evaluated by FDA. Typically, these devices will claim to treat the range of diseases, disorders, and have other uses that are not covered. And over the years, FDA has evaluated a number of ultrasonic diathermy devices, and they are all capable of heating deep tissue to a therapeutic temperature of a range of 40 to 45 degrees Celsius for the selected conditions. And however, there are various configurations with regard to energy output and applicator size. Furthermore, there may be instructions that apply only to a particular device. Therefore, it is important that you read and be familiar with the instructions for the particular device that you use. And you should also be especially mindful of all contradictions, warnings, and precautions that apply to the device. Thank you.